Hi guys, it's Miss Francis, and I'm going to talk to you today about water and why it's so essential to life, and we'll look at some of the properties that makes water so unique. So there are a couple of examples of organisms that use the unique properties of water in order to survive. Such as a lizard called the Jesus lizard that can actually walk across water to escape its predators. Well, why can the lizard walk across water but I can't? That's due to some of the unique properties that water has. Water is one of the only elements that exists in three possible states on Earth. It exists as an ice, a liquid, and a vapor. Water is what enabled terrestrial organisms to really evolve. And when scientists find water on other planets, they get really excited because they think, well, maybe that's a possibility that there might be some form of life there. And surprisingly, our cells are surrounded by water. Furthermore, within our cells are about 70 to 95% water. And that's important because that maintains the cell's structure. Without that water, the cell could collapse and die. Within a water molecule itself, it's held together by singular polar covalent bonds. Now, what makes up a water molecule? We all know H2O. What does that stand for? 2 hydrogen atoms and 1 oxygen atoms. And water is unique. It's a dipole, meaning that the opposite ends have opposite charges. So the oxygen is going to have 1 charge, whereas the hydrogen is going to have a different charge. Oxygen is known as more electronegative, meaning that it pulls the negative force closer towards it. So it's got a partial negative charge, whereas the 2 hydrogen atoms have a partial positive charge. So if we were to draw the water molecule, this is what it would look like, where we've got our oxygen with a partial negative charge and 2 hydrogen atoms with a partial positive charge. Now, due to these polar molecules, water has many unusual, unique properties because it is a dipole. Water is able to bond to a nearby water molecule where the partially negative oxygen can bond to the partially negative hydrogen, forming a hydrogen bond. And each water molecule can form hydrogen bonds with up to 4 of its neighboring water molecules. So here's what that hydrogen bond would look like, where the partially negative oxygen forms a weak hydrogen bond with the partially positive hydrogen. Like I said earlier, each water molecule could potentially form 4 hydrogen bonds with 4 other water molecules that are nearby. If I were to draw 3 water molecules and the charges and the bonds that appear between them, this is what it would look like, where I would represent the polar covalent bond within 1 molecule of water using a solid line, and the hydrogen bonds between the molecules of different water molecules as a dashed line. A question that was asked in class: predict which is the correct representation of the interaction of the water molecules, 2 different water molecules. This one, you see the oxygen interacting with the hydrogen, so this is the correct answer. Here, oxygen can't interact with another oxygen, they would repel each other. Here, hydrogen is interacting with hydrogen, they wouldn't repel each other. Furthermore, these molecules are drawn in a straight configuration. That would imply that this molecule is symmetrical and nonpolar. We know that water is polar and therefore asymmetrical. And here again we have what would look like 2 hydrogen bonded together, which we know wouldn't happen. The first property that I would like to talk to you that is unique to water molecule is cohesion. Water essentially sticks to or forms a hydrogen bond with other water molecules due to the polarity, where there is a partially negative oxygen and a partially positive hydrogen. This cohesion plays a key role in the transport of water against gravity in plants. So you'll see beads of water at the tops of blades of grass, right? The dew can form at the top of the blade of grass. Well, why doesn't that water droplet get pulled down by gravity? It's due to the cohesion, the property of water to essentially stick to itself. Adhesion is another unique characteristic or property of water, where water is attracted to other polar or other charged particles. This plays a key role in how water is transported through xylem as it travels upwards in plants. The water will adhere to the sides of the xylem, and the water will be pulled upward through the cohesion of that water. So why does it hurt so much when you do belly flop into the water? I mentioned that the hydrogen bonds are weak in comparison to the polar covalent bonds within the water molecule. So why would it hurt so much to do a belly flop? Well, despite the fact that those bonds are weak, there are so many of them that they form surface tension, making it difficult to break the surface of water. And this is why the Jesus lizard and this organism are able to rest on top of water. It's why a paper clip, if you put it in a glass of water, will float at the top of the surface. So surface tension is the measure of the force necessary to break the surface of the liquid. It would take a large amount of energy to break all of the hydrogen bonds at the surface of the water. All right, this is where I want to stop. Tomorrow we will start talking about other unique properties of water.